Fluid logic. Lasers. Semiconductor technology. Photo instrumentation. These diverse areas of investigation are only a small part of the research and development program being carried on by scientists and engineers of the United States Army Materiel Command Laboratories. This is the story of their work, the enormous scientific and technological effort which is constantly mobilized for the welfare and support of the United States fighting man. The story of the pioneers for tomorrow.
I'm Chief Warrant Officer Larry Albini from Chamois, Missouri. On 15 March 1966, I was flying a normal combat assault mission in the Delta region of Vietnam. Early in the afternoon, we were preparing to pull off station. I felt something hit my stomach. At the time, I didn't know what it was. I found out later it was a .50 caliber machine gun round. The chest plate I have on now stopped it. I owe my life to this chest plate.
This warrant officer's story is not merely an example of good fortune in combat. It is also an insight into the forward-looking work being carried on steadily throughout the network of Army laboratories and research centers across the nation. Installations such as Natick Laboratories near Boston, Aberdeen Proving Grounds in Maryland, the Tank Automotive Command near Detroit, Harry Diamond Laboratories in the nation's capital.
Hello, I'm Colonel Curtis of the Army Materiel Command. You know, when people consider what a soldier's needs are, they usually think of food, clothing, ammunition, a rifle. Well, that's part of it, certainly. But there's much more than that to fielding and supporting the modern defense force we have today. And it's from the cradle of science, laboratories like this, that the Army has pioneered the wealth of sophisticated materials and technology so essential to the success and safety of the American fighting man. Now, it's a big job, and not many people realize the scale of our continuing scientific effort. There are now some 500 major research and development projects and thousands of supporting tasks underway by Army R&D. And over the years, Army scientists have achieved many major breakthroughs, discoveries and developments in a variety of fields, which have benefited not only the United States combat soldier, but in many cases, all American citizens. But instead of me telling you all this, let me show you some of the things we've done and are doing.
Much of the research is highly sophisticated, delving into the realm of pure science, exploring the structure of materials or the nature of electromagnetic phenomena, such as lasers. Army research teams were among the first to recognize the full potential of the laser. Out of this has already come a remarkably accurate laser rangefinder. In operation, it emits a brief, almost undetectable beam to the target, and then rapidly calculates target distance from the time it takes for the beam to be reflected back. It can even be used in aircraft to lock on and provide a continuous reading of range. At the same time, in another Army Research Center, materials and methods are being developed to protect man from the potentially harmful effects of lasers. In the same way, basic research into even more exotic phenomena, such as plasmas, is underway at Harry Diamond Laboratories. Plasmas take on new characteristics under conditions of very high temperature and shock. Their strange properties are responsible for interference with spacecraft communication, as experienced by all the astronauts during re-entry. Here, extremely high voltage permits a plasma wave to be generated within this shock tube. Army studies like this are helping us not only toward advances in missile performance, but also are providing new insights into communications involving the ionosphere. Pure research such as this can often bear fruit in unexpected ways. For example, in searching for an instant underwater adhesive for demolition charges, Army scientists hit upon the technique of microencapsulation. In this process, the tiny adhesive resins and polymer particles are chemically coated inside a protective bubble, which prevents them from reacting with each other. Then, when pressure is applied, the bubbles burst, and the adhesive bonding rapidly takes place, even underwater. In the same way, whole new innovative processes, such as those being carried out in the Semiconductor Research Laboratory, have been generated by the Army. It was here, in response to the need for smaller and more rugged electronics, that the photo-etching technique for manufacturing integrated circuits in quantity originated. The process involves photographically reducing a complex circuit mock-up to pinhead size and using the tiny negatives to imprint the pattern onto the conducting material through etching. Without the development of this manufacturing method, the use of these semiconductors would not have been practical. Today, the same method is used throughout the electronics industry for the millions of semiconductors required in computers and other solid-state devices. But perhaps the most far-reaching example of the Army scientists' pioneering through basic research has been the discovery of a brand new, wholly unique technology known as fluidics.
Using air, water, or any other fluid medium, small units such as this may one day revolutionize both military and industrial control systems.
Though the components can be made of nearly any solid material, they can be made to sense, count, amplify, and control complex machinery, all without the need of electricity, and in most instances, without any moving parts. They can be used in everything from missiles to heart pumps, and can even replace electronics in some applications. In addition to these advantages, the devices are almost immune to shock, high temperatures, and even nuclear radiation. While continuing its pure research into fluidic phenomena, the Army is at the same time moving full steam ahead to develop some of the hundreds of applications foreseen for this remarkable new technology. For example, engineers have already come up with this unique fluid timing device. It is fabricated from more than 100 tiny plates, each etched so that when they are sandwiched together, they form a non-electric digital computer. It will function when rapidly moving air is provided as a power supply. This moving air is available naturally around the projectile or aircraft. Once set, the timer can control switches at any prescribed interval up to 5 minutes. It can survive conditions which would make other, more expensive electronic timers useless. One of the many potential medical applications for fluidic technology is represented by this Army-developed respirator, designed to regulate breathing and to aid respiratory problems. Surprisingly, the control mechanism of this sophisticated device is simply a small, unbreakable piece of plastic, cut with fluidic passages and operating automatically. The same principle has been employed in a related heart pump research project, in which these devices are under study as cardiac aids and even heart replacements. Safer, better jet aircraft promise to be another benefit of fluidic applications. For example, utilizing the unique characteristics of the technology, this temperature sensing device can be set right into the red-hot combustion chamber of a jet engine to measure the very critical heat levels. Its principle is ingeniously simple. The looping shape of the passages causes incoming air to be switched back and forth at a rapid rate. And because of the characteristics of gases, the hotter the air, the faster will be the rate of switching. Up to now, this kind of safety control had been impossible to achieve under the searing 3,500-degree conditions. Aside from numerous military applications, there are potential civilian uses for the fluidics technology that may eventually run the gamut from letter sorters to computers. For many years, much of the Army's research and development has been devoted to improving constantly the quality, capability, and reliability of the soldiers' transportation. But this, too, has often provided concurrent benefits to the American public in general. Engineers here at the Tank and Automotive Command Research Center, for example, are well on their way towards solving a problem with which we are all familiar, the flat tire. Up to now, tires had always been the most vulnerable point on many military vehicles. The answer may be this foldable tire, which has an inward folding section as part of its sidewalls. If it goes flat, the tire sidewall folds inward, but it remains firmly positioned on the rim. Most important, it is still able to carry weight, enabling the vehicle to be driven out of hazardous situations and as far as 300 miles without repair. And in case you're wondering, a commercial version will soon be on the market as a spare tire. In a related development that will also spell good news for American drivers, the Army is testing this new detachable tread tire. To change treads, the wheel does not even have to be removed from the vehicle, nor the tire from the rim. Eventually, commercial development of this technique will permit you to have such things as interchangeable snow tires. But engineers believe the military value will be even greater than the civilian value. In addition to saving a lot of money through drastically reducing the Army's tire budget, the detachable tread is expected to increase the tactical effectiveness of virtually all wheeled vehicles. How? By enabling them simply to change treads to deal with sand, mud, or whatever terrain conditions prove to be a problem. A more sophisticated money and time saver to come from Army research and development recently has been the MAIDS system, Multi-Purpose Automatic Inspection System. This is a computerized technique which can provide fast, thorough, and foolproof troubleshooting for any conventional vehicle, and without even getting anyone's hands dirty. Leads are attached to key areas of the engine to monitor performance of spark plugs, generator, valves, and timing. The data is then fed to a carefully programmed computer, which quickly analyzes the vehicle's performance and within a few minutes delivers a full report. This detailed breakdown not only points out what is wrong, but it spells out exactly what must be repaired or replaced and what repair parts should be used to do it. The great advantages in saved man-hours, materials, and repairs by using this system were apparent. Recognition by the automobile industry of this breakthrough was not long in coming. Today, similar commercial test centers are beginning to spring up all around the nation.
Of course, if a group of scientists at the Army's Mobility Equipment Research and Development Center has its way, fuel cells may make obsolete the MAID system as well as the combustion engine itself. This is a fuel cell, the most exciting new power source for the future. It bypasses the wasteful heat cycle of the conventional engine to deliver power directly by chemical reactions.
Compact and with few moving parts, a fuel cell can supply reliable and silent power for as long as its ammonia-like liquid fuel is provided. Field radios, lights, telephones, any kind of electrical equipment can be easily powered without betraying the squad's position. Fuel consumption of this device is only 1/4 the volume used by noisy conventional generators. Besides providing silent power, this device has a potential of improved reliability and long life operation before maintenance is required. Another practical development underway at the Mobility Research Laboratories may soon prove to be a boon not only to the Army, but to the construction industry as well. This odd-looking machine, known as red sod, repetitive explosive device for soil displacement, represents the first really new concept in earth moving since the advent of the bulldozer. Using special combustion chambers, this unit literally blasts the soil out of its way. Able to move earth 10 to 20 times faster than conventional equipment, the red sod is capable also of working in soils too wet or too adhesive for bulldozers. When fully developed, red sod is expected to save the Army a lot of time and trouble, and the U.S. taxpayer a lot of money.
Of course, Army researchers know that the soldier needs more than vehicles, weapons, and highly sophisticated equipment to do his best. Even more basic are the simple human needs of food and water. Yet these are not always so simple under combat conditions.
These soldiers are relying on the long-range patrol pack to provide full nutrition at a minimum weight. These aluminum foil packets contain a variety of familiar dishes. To prepare them, the soldiers only add water from their canteens. No matter how long the packets have been kept without refrigeration, the food looks and tastes almost fresh. This is possible because the entire meal has been freeze-dried, a process which was pioneered here at the Army's Natick laboratories. Frozen fresh, the food's moisture is then removed without permitting it to return to liquid form. When the food is reconstituted with water, the result is almost miraculous. While the American consumer today is confronted by many freeze-dried products in the local supermarket, he may not realize that they were made possible through Army research on behalf of the combat soldier. But far from resting on past and present achievements, Army research and development is constantly looking ahead, using every tool of modern technology to solve the problems of tomorrow before they become the problems of today. Prior research at Natick laboratories, for example, concerned the possibilities of developing common green algae as a major food source. Surprisingly, this primitive form of plant life has been found to contain high concentrations of protein and carbohydrates and compares favorably in food value with soybeans. In addition, it gives off oxygen and is able to thrive under very adverse conditions. Scientists here believe these characteristics make it nearly ideal as a nutrient source for space travelers and possibly for future generations of our crowded and polluted Earth. Similarly, hovercraft, such as these under development by the Army, may offer still another alternative to conventional modes of transportation. Riding on a cushion of air created by down-pointing jets, these craft can move up to 80 miles an hour over land and water alike. Already, an armed operational hovercraft has been used for river patrol action in Southeast Asia. With these many past, present, and future developments, the American soldier is never really operating alone. He is supported by the full scientific resources and capabilities of the United States Army laboratories, wherever he may be called upon to fight. Everything he uses, carries, wears, and depends upon for support is a product of years of painstaking research and development by scientists and engineers. These highly trained professional pioneers share one goal: to see that the American fighting man has the best there is for the job he has to do. Now and in the future, one thing is certain: as long as there are United States soldiers in the field, the work of the pioneers for tomorrow will go on.